100 years ago, Einstein presented his general theory of relativity for the first time before the Prussian Academy of Sciences. And at the time, it wasn't clear that there was a big gap in the theory to be filled. 2 years later, he applied his general theory of relativity for the first time to the cosmos, trying to present a new theory of the universe. And that theory also didn't reveal any kind of gap. According to Einstein's idea, the universe had a uniform density of matter and energy, and it was never changing. The universe was static. So everything was well behaved. There was no problem or gap in the theory. The only problem is the theory turned out to be wrong. A few years later, Alexander Friedman and Georges Lemaitre came along, and they showed that using Einstein's same equations, you could have other possibilities for the cosmos. You could have a universe which was expanding with time. And now the big gap became apparent. Because if you take that theory of an expanding universe and you extrapolate it back in time, according to Einstein's theory of general relativity, you reach a time, a finite time ago, when the temperature and the density become infinite. This is what mathematicians would call a breakdown or a singularity. It means there's something wrong with your theory. It may have been good at later times, but going back to this earlier time, there's a gap in the theory, something that needs to be filled with a new idea. Now, Georges Lemaitre had the idea that if you extrapolated back in time, all the matter and energy in the universe would compress into what he called a primeval atom. That idea never got very far. No one else picked it up. However, it had an element in it, the idea that what replaced the gap was some kind of beginning. And that idea does have a descendant in the current Big Bang theory. The idea of the bang is, if you like, a descendant of the primeval atom idea of Georges Lemaitre. Friedman had a different idea. He had the idea that the natural thing that would happen is if you went back in time, that the universe would bounce. So in other words, going forward in time, it would have gone through some kind of contraction and then a bounce into expansion. And these two ideas were both around in the early days of cosmology and the early days of general relativity. But the first issue to be decided was Einstein's static theory right, or was the idea of an expanding universe right? And that was decided by experiment. So here's a picture from the early 1930s, when the issue had been recently decided. It had been decided by the measurements of the fellow in the middle, Edwin Hubble, who had first shown that there exist galaxies that fill space, and then had shown that those galaxies are receding away from us. Most of them, except for our neighbors, are receding away from us at a speed which is proportional to their distance from us. And that is the characteristic signature of the Friedman-Lemaitre expanding universe picture. So that split off the static model as simply being wrong. A nice idea, but wrong. And revealed the big gap. Now, Einstein had a decision to make. Which of these ideas would he favor? The Georges Lemaitre idea of the primeval atom or beginning, or the Friedman idea of the bounce? And actually, if you look at the literature and the archives, it's not completely clear. But if you look around this time, when this picture is taken, the 1930s, at that time, there was a clear decision on his part to favor the idea of the bouncing universe. In fact, not just a universe that bounced once, but Friedman's idea of a universe that bounced at regular intervals. That's what Friedman called a periodic universe. Einstein worked on it, lectured about it, but didn't publish on it because by the time he had thought about it a little bit further, he realized there was a problem with this idea, which is that if you took Hubble's measurement of the expansion rate of the universe and put that into this theory of the periodic universe, you ended up with a theory which said that the time interval between these bounces was shorter than the ages of the stars and planets. So he saw a contradiction. And so he didn't write further about it other than to point out the contradiction. Now it turns out that this problem with Hubble's measurement was not a problem of the theory. It turned out to be a problem of Hubble's numbers. And not so much Hubble's measurements, but the numbers measured by other astronomers which Hubble was using its input to get his expansion rate. There was a problem there, but it took decades to settle it. It wasn't until the 1950s before it got settled, and by that time we have no further opinion from Einstein on which idea he favored. In fact, by that time we understood a lot of new things about physics. We had a much better understanding of quantum physics by that time, and the protagonists had changed. Now the debate was between the steady state model as represented by Fred Hoyle and the Friedmann-Lemaitre picture as represented by George Gamow. And there was a famous set of radio debates on radio between these two protagonists about the two theories. And Hoyle was a very charismatic radio personality, and he decided to introduce a term to belittle the opponent's theory, the Friedmann-Lemaitre theory. And the term he introduced was Big Bang. He referred to it as the Big Bang theory, figuring that if he could belittle it in this way, people would take it less seriously. Now, unfortunately, the name has stuck. And it's still the idea that we use today. It's rare to have a theory named by an opponent, but that's what happened in this case. But what's especially bad about it is that it tagged the theory, the Friedmann-Lemaitre idea, with just one idea, the beginning idea. It lost the possibility of a bounce, even though Friedman and Gamow would have perfectly allowed that possibility and were open-minded about it. The idea of a bang being associated with Friedmann-Lemaitre became merged together. And they've remained merged together up until the present time. So that when most people talk about our
talking whether or not a new theory